In this example, we want to write the equation for the line tangent to the curve y equals the square root of x divided by x minus 2 at x equals 3. So to write the equation for any line, we need both a point and a slope. So let's begin with our point. We've been given the x value of our point, but now we need to obtain the y value of our point. So we'll do this by substituting 3 into our function. So y equals the square root of 3 divided by 3 minus 2, which will be the square root of 3. So the y value of our point is square root of 3. Now next we've got to figure out our slope. So in this case, the slope is going to be the derivative of this function evaluated at 3. So we need to begin by computing the derivative. But we'll notice this function is actually a composite function. So since it's a composite function, we are going to use the chain rule. And it might be helpful to first rewrite this function. Instead of it written as a square root, we might want to rewrite it as the quantity x divided by x minus 2 to the 1/2 power, because then it's more easily seen as a composite function. So a composite function has an outer piece and an inner piece. So we'll begin by identifying the outer piece, which I call f, and the inner piece, which I'll call g. So our outer function is something raised to the 1/2 power, and then our inner function is x divided by x minus 2. So to compute the derivative of this function, we're going to use the chain rule. So chain rule begins with the derivative of the outer function. And since our outer function is a power function, we're going to use the power rule. So the derivative of something to the 1/2 will be 1/2 something to the negative 1/2 power. And remember, that's because we subtract 1 from the exponent. And then we'll go ahead and input the original inner function, which is the original g function, which is x divided by x minus 2. Now the chaining comes with multiplication, and we need to chain on the derivative of the inner function. But you'll notice that this inner function is a quotient. So we're going to need to use the quotient rule to determine the derivative of this function, function g. So using our little memory trick for the quotient rule, low d high minus high d low divided by low squared, we'll start with the function in the denominator, the low, which is x minus 2. We'll multiply it by the derivative of the function on top in the numerator. The derivative of x is just 1. So that's low d high minus the function in the numerator, which is x, times the derivative of the function in the denominator. The derivative of x minus 2 is just 1. So that's low d high minus high d low, all divided by the denominator function squared. So we'll divide by x minus 2, the quantity squared. So now we need to simplify a bit. We have 1/2 the quantity x divided by x minus 2 raised to the negative 1/2 power. And then you'll notice in the numerator from the quotient rule, we really just have x minus 2 minus x. So my x's subtract out, leaving me with negative 2. So we have negative 2 divided by the quantity x minus 2 squared. So this is our derivative. Looking back at our goal, we need to compute the derivative at 3. So now we're going to go ahead and substitute 3 into this derivative. So substituting 3 into our derivative, gives us 1/2 times the quantity 3 divided by 3 minus 2 to the negative 1/2 power times the quantity negative 2 divided by 3 minus 2 squared. So we need to simplify a bit. Since 3 minus 2 equals 1, we'll be left with 1/2 times 3 raised to the negative 1/2 power times negative 2. So you'll notice then the 2's divide out. So now we're left with negative quantity 3 to the negative 1/2 power. Now the negative exponent, remember, is going to create a fraction, so we'll have negative 1 divided by 3 to the positive 1/2 power, which is really the same as negative 1 divided by the square root of 3. And I don't mind for my students to leave this as their slope. I accept this answer for the slope. I realize that some instructors may want you to rationalize the denominator. So if you want to go ahead and multiply by square root of 3 over the square root of 3, you certainly can. So then your slope would be negative square root of 3 over 3. And that would be fine as well. So if we go back to the beginning, where we were trying to find our slope, we now have the slope at 3. So the slope at 3 is negative 1 divided by the square root of 3. So now we can actually write the equation for our tangent line. Since we have a point and a slope, I will use point-slope form. So y minus the square root of 3 is equal to negative 1 divided by the square root of 3 times the quantity x minus 3. And that would be the equation for our tangent line written in point-slope form.